Well, my name is Judd Stretcher with Continental NH3 Products. A lot of new faces here, so I see a lot of you, but a lot of new faces. But um, I'm glad I showed up a little early. I'm pretty impressed by Tom's presentation. I've always enjoyed working with FDS, especially the crew that you guys have here. It's always a joy. You guys always seem to be interested in what I have to say. Y'all don't nod off in my presentations, which is kind of nice. Even though I can be boring sometimes. But anyway, I appreciate the opportunity. We don't get many opportunities to come up and do training, so I really appreciate it. And if you guys got any questions when I'm in the middle of it, just blurt it out. I'm always going to give opportunities to ask questions, and if you can remind me to repeat the question so that the audio will grab it, I'll do it. Okay. So what I thought we'd do is just review the cooler in a little bit detailed. We'll talk about features. We'll go into the properties of ammonia and how it relates to the cooler, how the cooler works in the auto rate control system in general. Then we'll cover some flow rates and kind of expectations and how we get those flow rates. And then we'll tap into some troubleshooting. And then throughout, it's question and answer. Obviously we'll finish off with some Q&A, but if you have anything in the middle, just go ahead and blurt it out. So we got a unit up here. I'll kind of grab it here in just a second as we review them. But if you have any questions, just holler, okay? We'll start off with some of the primary, get over here, some of the primary features that we have in our cooler. One, which we've had for a while, but we were the first ones to actually do it, which is have stainless steel components on the inside. Rusting was a big issue many years ago, and it still is. In-serve is always going to be a component, and when you have in-serve mixed in with ammonia, you're going to have some rusting issues. So one of the primary components we have on the inside, all this here is stainless steel, along with the O-ring bonnet, and as well as on the inside. The outside is not. The bodies are not, but the inside, where all the rusting components takes place, those are going to be stainless. So they really last a long time, which sometimes is a bummer when sales come around. You always like to replace equipment, but it does do a really good job of lasting a long time. And we've had a really good jump in that. People tend to like that a lot. We've had continually improving on our stainless steel features. We've got a lot of stainless on the inside as well. The feeder tube inside, as well as the outlet here, is also stainless to prevent rust. Another feature we incorporated a couple years ago is a flushing internal flush valve. Okay, what this feature does is allows you to drain the cooler out the dump lines. So if you guys are familiar, a lot of guys, how many guys kind of come from the application industry? A lot of guys do. So, when you're trying to drain a cooler out in the field, it's in the middle of the bar. It's not easy to get to. So this will allow you to crawl off in there, crack open the bleed valve, the flush valve, and allow all that ammonia to vent out the dump lines. So instead of it just bleed right in your face, you can dump out the dump lines. It's a lot safer. Okay. Also comes with a breakdown bolt, which is not here, but anyway, it should be. It's right here. So what this feature does is when you're trying to take it apart, when it's in here, when you're trying to take it apart, a lot of guys will try to use a pipe wrench, screwdriver, hammer it in there, try to separate the two pieces. You'll end up damaging them. So what this allows you to do is you just thread the bolt in here with an Allen wrench. You can get an impact wrench or anything like that. And when you hammer at that end, it presses up against the body and then separates the two pieces. So, it's just a lot easier to get apart, especially after a couple of years. Heck, these things might not come apart for 10 years, So it's always good to be able to use this breakdown bolt. Comes apart really easy. Just another step in getting it apart.
That's not in the cooler all the time. Is that a separate piece that they're going to have?
No, that comes with a cooler, and
that's not installed in the cooler, right?
Yeah, no, it's installed. Okay. Yeah, it's in here. If you can it'll be right in here, just like you see here. And now when we install it at the factory, it's kind of installed tough. You know, we kind of crank it down so it doesn't jiggle loose, but it will come loose in the field. So it's possible this one here might have just jiggled loose in the field. But, you know, you don't need a special bolt. You know, it's a 3/8 13, so it's pretty easy to get. If you can go to the hardware store and pick them up. So, but yeah, it does come installed new into the unit. Okay. Also comes standard is our dump orifice valve. This is a feature that we incorporated about 8 or 9 years ago. It's a really neat feature. What it does is controls the amount of cooling refrigerant ammonia going into the cooler. And that's kind of the fuel. It's kind of the gas. And we'll talk a little bit about that later. But that's kind of the gas that makes the system work. Okay. So the cool thing about this is it's external and it's easy to switch. It's easy to change, control the amount of ammonia that's going to it with just a wing nut. Turn it to where you want, tighten it back down, you're ready to go. So your custom app guys, the guys who are doing one rate in one field, another rate in another field, you know, you want to control the amount of ammonia coming out of those dump lines. And this is a great feature to do that with. The old school way was through a hose barb, which is a pain in the ass to swap in and out. You know, the other guys use a threaded in Allen orifice, which is real difficult to get to. This is a really nice little feature. A lot of guys don't, at first when we first introduced it, it was confusing. People didn't understand it. But once you get the hang of it, once guys understand what it does and how it works, they love it. In fact, we do a lot of sales after they buy these things and put them on their older units because it's so easy to use. So that comes standard with the unit as well. What did I miss up here? Breakdown bolt. This cooler can. The one thing cool about our product on this line is one cooler does everything. You don't have to worry about multiple coolers doing different rates. Our cooler is, this thing will do 10 gallon a minute, 15 gallon a minute with 1-inch hose, but it'll do 70 gallon and 80 gallon a minute with 2.5-inch hoses. So you don't really have to concern yourself with the guy comes in the door and he's got an old 12 outlet bar and he pulled out of the weeds and he needs a new cooler. Well, do we give him a smaller unit or a guy who's got a 62.5-foot bar? We got to, give him the bigger unit. It's all the same unit. It all depends on how you plumb it. And we'll talk a little bit about that when it comes to flow rates, how plumbing affects how fast you can go. So we'll touch that. We'll touch on that a little bit later. And of course, the repair kit is pretty standard. Standard O-rings, which is a pretty neat feature, especially on the weekends when he's down, nobody's open. Friday, these things always break down Friday afternoon, and you can't get any parts. But the cool thing is he can go to any O-ring shop, any automotive shop, really, as long as it's the correct compound. He can pick up these O-rings anywhere. So that's a pretty neat feature when the guy's down and out and he needs to be running over the weekend. So that's a pretty cool feature. Okay. Are there any questions on some of the features? Yeah.
Not really a question, but the breakdown bolt, when you take it out of the packaging in the box,
yeah,
that breakdown bolt is labeled just for information.
Yeah, he asked about the breakdown bolt, whether it's labeled. And yeah, when it's new, this bolt here is actually threaded into the unit with a tag on it that tells you it's a breakdown bolt. That's a good point. So it's pretty easy to identify what it is and what it does. Good question. Yes, sir. Yes. He asked about say that again. Diagrams. I don't have a diagram, but we do have in here a little while. We have a chart that shows flow rates based on nurse tank size, tank pressure, and hose sizes. We'll talk about that in a minute. Yeah. Yeah.
You were mentioning about the flow rate through your orifice. Give us some ballpark. What kind of anhydrous is moving through that? What percentage of the total anhydrous, or however you rate it?
Yep.
How do we make that decision?
Yep. And I'm going to touch on that in just a second. Yeah, we'll talk about the orifice, what they're rated, A, B, and C, and D, and what you use when you use it, and how much a percentage we use to make this system function. Okay. All right. Okay. I figure we talk a little bit about the properties of ammonia. I think if you got a better understanding of how ammonia works, I think you have a better idea of how the unit works and when it comes to troubleshooting and selling. Okay. Ammonia is a pressurized gas, which means while it's under pressure, it's in a liquid state. When it's not, it vaporizes. Very similar to propane and freon. So if you guys are familiar with propane and freon, it's just like ammonia, okay? The expansion rate is 600 to 1. So that's where the problem lies when we're trying to control ammonia, when we're trying to put it on, is the expansion rate. So if you can kind of imagine, get your mind's eye on a gallon in volume, 1 gallon jug of milk turns into 600 gallons of vapor. So you can fill up a nurse tank in vapor with 2 gallons of liquid. So, you know, the expansion rate is huge. So anytime you're trying to control ammonia, when you have a pressure drop and it starts vaporizing, you know, you got to deal with this vapor. So if you can kind of, you know, when you're coming out of your nurse tank, you know, you have a pressure drop. Every time you have a pressure drop with ammonia, it vaporizes, okay? So, and as soon as you open up your valve, as soon as it comes out of your nurse tank valve, you've got vapor, okay? At the higher pressures, you got less vapor, probably 70% liquid, 30% vapor. But you get down into the lower tank pressures, like 50 pounds, you got 50% vapor, 50% liquid. You get down into the 40 PSI range, you got 60% vapor, 40% liquid. So, you know, kind of thinking about fall, apply ammonia, how it's cold, low tank pressures. I'm sure everybody's fielded that call. You know, I'm having to slow down. What the heck's going on? A common misconception is, well, I just don't have enough tank pressure. And that's true. I need pressure to get out of the tank. Well, it's not really the tank pressure is the problem. It's the vapor. It's the vapor bubbles. The vapor bubbles are twice as big. So the cooler has to work twice as hard. So, you know, at 100 PSI, when that ammonia comes in, it's got, you know, this much liquid, this much vapor as it comes in. Well, when you're at 40, it's the other way around. So when it comes in, the cooler has to cool these huge vapor bubbles back down, and that kills your capacity. So you're going to lose basically 50% from 100 to 50 PSI. You're going to lose 50% of that, and then below that, it's 1 to 1. So it's a pretty significant reduction. So if you kind of think about how that works when it comes to coolers, you'll have a kind of a better understanding. Some of the stuff is pretty straightforward. You guys know this. It boils at 28 degrees below zero. So when it's not under pressure, when it's coming through, as soon as you get a pressure drop, it starts to boil. Boil, I don't want to make you think it boils like water boils, but it bubbles, you know, so that's what they call it, boiling. So when it comes out of the tank, as soon as you get a pressure drop, it starts to vaporize. And it wants to get down to 28 degrees below zero. And at that point, once it gets down to 28 degrees below zero, it's basically like water. It doesn't boil, it doesn't do anything, it just sits there, okay? That's what it wants to do when it's not under pressure. 82% nitrogen by volume. I think that's pretty straightforward. You guys are aware of that. Temperature of the ammonia follows the ambient temperature. So this is something that a lot of people don't understand. You know, when it's 80 degrees outside, the liquid in the nurse tank is 80 degrees. When it's 50 degrees outside, the liquid is 50 degrees. So the pressure is going to follow that temperature. So the higher the temperature, the higher the nurse tank pressure. The lower the temperature, the lower the nurse tank pressure. But when you're talking about cooling, you know, if you kind of think about this, when it's cold outside, let's say a guy gets out in the morning and it's 35 degrees. Well, the ammonia is 35 degrees as well. So to get it out of the nurse tank, you know, you got that pressure drop. So it's already starting to cool. So when you start cooling, that temperature of the ammonia starts to drop. So by the time it gets into the cooler, it's probably 30 degrees. And now you got to cool it on top of that 30 degrees. So it gets to be increasingly more difficult to cool those vapor bubbles down the colder it gets. And then you have the large vapor bubbles that makes it even harder, okay? Anybody have any questions? I know it sometimes gets a little confusing, but I think if you kind of understand how it works when you start talking about the cooler, I think you have a better understanding of how things kind of jive, okay? All right. How the cooler works and why it's needed. You know, all the systems based on liquid, so we got to be able to read the liquid as a solid. We can't have any vapor in the system, so the cooler is there to cool the ammonia, the vapor, back down to liquid, so when it goes through the flow meter, you can read it accurately, okay? So what is needed is about 2 to 3% of the product to cool the rest of it back down to liquid form. And that's where this comes into play, okay? So what this does is control that 2 to 3% to cool the rest of it back down to a liquid. So you've got 4 options in here. You got A, B, C, and D. You know, A is good from, 1 to 10 gallon a minute. B is 10 to 20. C is 20 and up. D is there for guys who have trouble with in-serve plug in their cooler. We won't go into that. But that is what it's going to control, that 2 or 3%. If we didn't have this, we'd be dumping a whole lot of liquid out of those vapor lines. And that's what we don't want to do. We really don't want to dump anything out. We only want to use what we need. If the cooler doesn't need it, it just dumps it in liquid form, okay? And then you'll end up contributing too much nitrogen on those vapor lines. I'm sure at some point you guys have heard from guys that, I got 4 lines every so often. My corn's, 3 foot taller than the rest of it. Well, that's because he put too much liquid out of his dump lines, okay? So that's what this is for, and that's why it's so crucial to use it correctly so that we can control it. If a guy's doing a side dress at 10 gallon a minute, we want to use 2 to 3%. If he's doing fall apply at 30 gallon a minute, we still just want to use 2 to 3%. So we have to control that with this orifice valve, okay? Does anybody have any questions on that? Okay. Okay, we got that. So this is a chart that it gives you an idea of flow expectations based on tank pressure, nurse tank size, hose sizes, number of hoses, okay? As you can see, if you got some of the smaller guys, 1.25 inch hoses with a single 1,000-gallon tank, at 100 PSI, he's only looking at, I don't know why I painted this green. Can you see it okay? I thought green was good at some point. I'm not thinking so good now. White would have been better. But 1,000-gallon tank, 27. At 50, you're only looking at 20. At 40, you're looking at 18. So there's a huge, significant difference when tank pressure and tank size. And the tank size, it's a little deceiving. It's not really the size of the tank, it's the dip tube in the tank. So I use single 1,000-gallon just because that's common. If we start talking dip tube size, people get confused. So 99% of 1,000-gallon nurse tank have the small dip tube. 99% of the 1450s have the bigger dip tube. So it's just easier to associate smaller dip tube, 1,000-gallon tank, bigger dip tube, 1450, okay? So as you can see how big a difference it is. You start off with an 1.25 inch hose, single 1,000-gallon tank, you see where we are. You get into a single 1450, you're jumping it up 10%, okay? You get into dual thousands, you're jumping to 44 gallon a minute. You get into dual 1450s, you're up to 52 gallon a minute. So it all plays, the supply is critical when it comes to capacity. That's why earlier when I said that our cooler, it's the same cooler, whether you want to do 27 gallon a minute or you want to do, 75 gallon a minute. It's the same cooler. But what's going to play a part into what you can get is your supply. That cooler is just like a motor, a 350 engine. You can get a 350 block engine, put it in there, and you get 200 horsepower. Well, you can take that engine, get it to a performance shop, he'll put a turbo, all this other junk on it. Next thing you know, that thing's doing 400 horsepower. Okay, so it's the same principle. We got to feed it. We got to feed it, and the more we feed it, the faster it'll go. So that's crucial when the guys are trying to establish, what he needs to get the rate he needs. And if you guys have a better understanding of what he has when he starts calling and saying, hey, I need a new cooler, or man, I'm not going fast enough. How do I improve? What can I do to go faster? This is a great chart. I always start off with, well, what kind of tanks do you get from your co-op? Most people, and now the custom co-op, some guys have their own tanks, but most of the guys they got to deal with what they get from the co-ops. They got to live with that. And so the guys may, they get single 1,000-gallon nurse tanks. It's going to be tough to get what he wants. So review what he's got coming from his co-op, and then you'll have a better idea of telling him what his expectations will be. Okay? Again, these are estimates, so every bar is a little different, and I have seen some plumbing nightmares. I have no idea how some people even get ammonia out of nurse tanks, some of the plumbing I've seen. So that's important too, So it's shockingly how many different ways that you can plumb something is incredible. I mean, I think there's only one or two. There's hundreds, and most of them are wrong. Are there any questions on this? But just keep it in mind, these are estimates. These are just guidelines. So this will kind of give you an idea, of what to expect. Okay. Yeah, I think this is y'all. Kent, this is in. Yeah, you guys are going to have all these, so you can print out whatever you want. Okay. Okay. Troubleshooting. What I thought I'd do is just kind of run over some of the troubleshooting that I've run into, and some of the things that I do to narrow it down to try to help. Kind of separate it out to two sections here. One, not getting enough. Two, dump lines dump all the time. So when they're not getting enough and having to slow down, that's one of the first phone calls I get. And I always go, like I said on the earlier slide, I go straight to what are your nurse tank sizes and what do you have? Because a lot of times that's his problem. Again, with the internet, the guys go on the internet, they see 70 gallon a minute. They think, okay, man, they don't read the small print. They go straight there. They order a cooler. They put it on there. And then they wonder why they can't go 8 miles an hour and they're doing 4. So I always review the system to make sure their plumbing is sufficient. Okay. Dump orifice size selection is the next step. When they've got this dump orifice selector here, we want to make sure that he's got the right selection. And I made it pretty easy. A, B, C, and D. A is going to be 1 to 10 gallon a minute. B, 11 to 20. C, 20 and up. Okay. A lot of times you can just ask them if there's any any frost on their vapor lines, which would indicate liquid. If they're not getting any frost, more than likely the dump orifice is too small. When you're troubleshooting, you want to see a little bit of frost on those dump lines. That helps. That tells us we're getting sufficient refrigeration. If you're not getting any, that doesn't mean it's bad. Somebody calls and says, "Man, I'm not getting any frost on my dump lines, but everything's fine." And leave it alone. I mean, that's a perfect world. We get to refrigerate we burn up all the liquid into dumps and vapor. That's perfect. But if it's not working, then we need to see a little bit of liquid. You got any questions? Make sure you blur it out if you got any. So this is another check orifice valve installation to make sure this is in the correct orientation. There is a specific way that this needs to be mounted, and it's critical. The way the system needs to be fed is, if you can kind of think of your control valve and everything here, when you come into that T, you want a dead head into this orifice valve and then bend out to your manifolds. A lot of guys will put it the other way around because it's convenient. Well, I'm going back to the cooler, so I'm just going to put my T like that and go straight through the T into my manifolds, and I'll go up and back to the cooler. That's not going to work, especially with the larger toolbars. Okay, the smaller toolbars can get away with it because their demand is really low. But the bigger toolbars, we really need to deadhead into that orifice valve. We need to come straight in, crash into that T, and what that does is come in here and pushes it back to the cooler so that we can get it fed. Okay, and then we bend it out and go to our manifold. So that's another area that we see a lot of. Yes.
Whether that is closer to the T or closer to the cooler?
They ask if whether it's closer to the T or closer to the cooler. In our tests, it has not shown any difference, but we put it closer to the T only because it's just easier to see and easier to get to. Because there is a little window in here. I don't have my glasses on. I don't even see anything. Tell we're getting older. But there's a little window in here that is labeled A, B, C, and D. So it's a little bit easier to read when it's out on the T. If it's underneath the cooler, really hard to get to. The guys are, it's hard to get to. So when it's out on the T, it's a little easier to see. But when it comes to performance, we haven't seen any difference at all. In fact, I've had guys, when we're troubleshooting and we're real struggling trying to figure out what's going on, I've had them, that are attached to the coolers. We've had them moved, because we're just scraping the bottom of the barrel trying to figure out why he's not getting what he's getting or he's supposed to be getting. And we've moved it and it's made no difference. So, but it does make a difference when it comes to accessibility. Okay. Check to make sure the vapor lines are 3/4 inch. I know this seems to be pretty standard. I don't know why anybody would do it, but we have a lot of guys who want to try to cut a corner and they don't like using a 3/4 inch vapor knives. So what they'll do is they'll take the barb out, put a T in there, and run 1/2 inch hoses. And then then some actually try to tie them into an applicator hose, which is a really bad idea. But when you cut down, everybody thinks, well, 2 1/2 inch hose is equal to 1 3/4. Well, that's incorrect because of square area. Square area of a 3/4 inch hose is bigger than 2 1/2 inchers. So if he's going to do that, he can. He's just got to go to 3 on each side. So it's a total of 6. So just make sure that that he's got the 3/4 inch line plumbed properly. Okay. Lastly, we run into this a lot. Check manifolds and splitters to make sure they aren't too small. Okay. In the colder weather is where this really plays a part. Some manifolds out there have small orifices in their manifolds, and when tank pressures are high, no big deal. When tank pressures are low, it's a big deal. So if you can kind of think, let's say I'm an applicator and I'm trying to get 200 pounds in, all right, and I've got back pressure in my manifold. It's 100 psi early in the fall. Everything's great. I've got 65 psi in my manifold. Okay. Well, he needs 65 psi in that manifold no matter what tank pressure he has. If he's got 300 pounds of tank pressure, 65 psi in the manifold is what it's going to be to get that 200 pounds. Well, if you can kind of imagine when it gets cold, it gets down to 50. He doesn't have enough. He needs 65. He got 50. He's never going to get there. So what we need to do is open up the manifolds. Okay. Open up the manifolds, drop that back pressure so we can get more flow out of it. And so as a general rule, 70% of your pressure in the manifolds is where it gets to be a problem. This is on non-pump driven systems now. 70 psi. So if he's got, just to make it easy, if he's got 100 pounds of tank pressure, once you get up to 70 in your manifold, it's starting to back up. Okay. And even if he gets 80 psi, 90 psi, it won't flow anymore. The vapor in the system prevents the more liquid getting out, and it just backs up. Okay. So if you got guys that are struggling, especially in cold weather, look at his manifold pressures. It's real easy to do, manifold and tank pressures. And if he's running into that 70, 80%, especially if he's at 90%, it's a no-brainer. If he's got, I've got 50 pounds of tank pressure and I've got 45 pounds of manifold pressure. Way too small. So look into getting larger manifolds. We have jumbo splitters and jumbo manifolds that will help, open it up, let the system breathe, get bigger orifices, drop that back pressure down so that we can get more out. And a symptom of too small manifolds is fluctuating rates, and of course, being just backed up. He'll say, "Man, I don't understand. I got 200 pounds and it just says 150, and it won't get any more on." Well, it backs up and it just won't allow any more on. Okay. Is there any questions on that? Yes.
What manifold do you have that has the wide openness?
Yeah.
What would you choose?
Yeah. So our largest manifold is the Jumbo 360 series, and it's got the largest orifice. It's about 356 is the actual measured size, which is pretty significant. It's pretty large. Some of our other competitors only run a 187 hole, so it's a lot. Not 350, sorry, 256. So it's a lot bigger than what you're going to see in some of our other competitors. Yes.
And that manifold still has your equalizing?
Yes, yeah, that's right. The 360 does a really good job at distribution at a wide range of application rates. Even at a low, we haven't quite committed to making the jumbo our standard. So we're still offering a corn and a jumbo. We're going to do a little bit further testing on lower rates to see if we can just commit to the jumbo for everything, which would make it a lot easier. But we haven't done that yet, and we don't like doing anything without testing it, 10 times. So, but we're looking at doing that in the future. That way, a little bit easier for you guys to be able to sell and be able to handle everything with just one manifold. Okay, Todd, did you ever? You good? Okay. All right. Yes.
We've seen more and more strainers going in that refrigerant line.
Yes. Yeah. Yep. Yeah.
I think that's a good idea.
No, it's a good question. They asked if a Y strainer to strain before the orifice valve, correct? To go into the refrigerant line.
Typically they do it after that selector valve, and just in line on that.
Oh, really? Okay. Okay. Well, I would put it before, because what we see, and this happens in the South, because we apparently don't care about equipment down there. You guys take a lot of care down in Texas. You don't know what the hell you're going to get. So it's really rusty nurse tanks and really dirty, and that orifice valve, this orifice valve, will get plugged. So we don't. If you're having trouble with that orifice valve getting plugged up, we recommend a 1/2-inch Y strainer. Now, I know this is 1/4-inch pipe, but the 1/2-inch Y strainer has more area to fill up before it gets to be a problem, before it gets to plug. The 1/4-inch ones are just a little too small. So you got to kind of bush it up and down to make it work, but it lasts a lot longer. And usually guys either have a lot of problems or no problems, okay? So yes, a Y strainer is a great idea. We haven't gone to be a standard because most of the guys don't have that problem. And but it is something that you can add, but use a 1/2-inch Y strainer. We think it works better. Okay. Yes. I do not make the strainer. We just sell it. It's a.
No, that's what I was getting at. We can get it from you.
Yes, sir. Yeah, absolutely. Yep. Yeah, you can get that. 1/2-inch. Yeah, and what you'll do is just bush up and bush down. Is usually the easiest thing to do. Okay. All right. Any questions on that part? Okay. Dump lines dump all the time. This is one of the ones that is kind of frustrating for guys out in the field. But I'll tell you, 99% of the time, it's not the cooler. But 99% of the time, they blame the cooler. So we always get this call after 3 days of him taking the cooler apart, swapping out the O-rings, and he's madder than a bear cat, So if this is it's usually one of these two things 99% of the time. And the first one is usually the one that really gets them the red ass, because they'll jack with it for 2 days and realize they had a stinking valve open. So just check that remote bleed valve, which is right here. A lot of times, guys, after the season, they crack that valve open and they forget about it. When they come into the season, these guys really aren't used to it. And it looks like a bleeder valve. I mean, from a distance, you're looking at it, it looks like a bleeder valve. So when you turn the system on, they expect if it was open, it'd be spraying ammonia everywhere. But it's not. It's actually internal flush system. So when it's cracked open, it bleeds out the dump lines. So first step, I always say, check the flush valve, make sure it's shut down. And man, about 70% of the time, the guy goes, oh, shit, and then hangs up and off he goes, okay? The second one is a little more difficult, but it's an easy test to run. Most of the time we find the shutoff valve is not either is failing or is leaking by. With the proliferation, is that the right word? I'm not even saying it right. When sectional shutoff valves are everywhere now. Everybody's putting valves on their manifolds. Well, now that we've done that, it kind of traps the ammonia and it doesn't allow it to go out the manifold. So rewind 15 years ago, we didn't have those. So when your primary valve leaked, it ran out the lines. So everybody doesn't think that, hey, you know what? If that primary valve is leaking, they keep looking for it to come out of the applicator lines. Well, with the sectional shutoff valves, it traps the ammonia. Well, when you do that, the ammonia leaks through and then back feeds through the refrigerant line and out the dump lines. And the first thing they think of is cooler's bad. Something's wrong with the cooler. I got to put a repair kit in it. So it's a really easy test to run. Just tell the guys you got to, drain your system. Obviously, you want to start off it with a completely empty system. Just remove that 3/8 refrigerant line that goes from that orifice valve to the cooler. Just disconnect it and give it a little juice. Okay. When you do that, the ammonia will come out of either the cooler, continue to come out of the cooler, which means you want to put a repair kit in it, or it'll come out of the orifice valve, which means you got a bad shutoff valve. And 9 out of 10 times, it's that shutoff valve when you get to that point. These coolers, we test them before they go out the door 3 times. We get 3 stages of testing. This one gets tested once, this one gets tested twice, and then the whole system gets retested after powder coat. So especially on a newer cooler, if anything, 5 years or newer, it's just unlikely the cooler's bad. Now, it's possible you might have a bad O-ring, something in there. I get that, but, it's just unlikely new coolers are bad. We just test these so much as we really don't want anybody having any problems with newer coolers when they get out there. So it's just unlikely it's a bad cooler. That's the last step I go to is, now let's go looking at that cooler. I'd look at everything else first, okay? Is there any questions on that?
Not really a question, but
Yeah.
an observation from my customer about the remote bleed valve.
Yeah.
Since it's so close to the mounting bracketry, he goes, "What are you talking about?"
Yeah.
Underneath, it's hidden.
Yeah.
He looks
No,
like-
it's a good point. Yeah, it is kind of close to the mounting bracket. It's kind of hard to see, actually, So I try to tell them it's, in the bottom between the inlet and the outlet, some right around in there. And usually what I usually tell them is it looks like a bleeder valve, and that usually, oh, yeah, I know what you're talking about now, But yeah, that it is an unusual location. And with the bracket sitting right here, it's kind of hard to see especially if you're coming at this angle instead of the back angle. Yeah. Any other questions? Good. All right. I think so. We got a little bit of time. I thought we'd just talk a little bit about the control valves. You guys have been really kind and allow us to purchase some of our control valves and shutoff valves that we have now. I can't thank you enough for that. I really wish, I talked to Lucas about this a little bit. I really wish KZ was giving us more motors to supply y'all's needs, and it's very, very frustrating to have an opportunity and can't take advantage of it. So, but we're going to do whatever KZ allows us to do, and but we sure appreciate you guys. But I thought might just go over a few things while we have a little bit of time. The shutoff valves, we have a full line, 1 inch, 1 1/4, and 1 1/2. The shutoff valves are really shutoff valves. There's not really much to them, so I'm not really going to cover any of that, but I will cover the control valves, which this is one right here. The unique feature about this valve, and this is 1 1/2 inch, so it comes 1 1/2 inch and 1 1/4 inch. It's a 1 1/4 inch through hole, so it's a full port for 1 1/4 inch. It's full flow for 1 1/2 inch. So, which means it'll flow as much as 1 1/2 inch hose will, okay? Which is more than what you're ever going to need, all right? The cool thing about this is it's 120 degrees of control. Normal ball valves are 90 degrees. So we've got an extra 30 degrees of movement on that valve. And it's a weir. So the angle, if you can kind of imagine a ball, normal ball valve looks like this, right? Well, ours has an additional V cut in the ball. So it kind of looks like this. So when it starts to open up, it comes into the V portion of the ball. So it's a very smooth linear move when you start to control. A ball valve goes like this, whoop, and then comes up. Ours makes a nice smooth transition. So when you're talking about controlling on low volumes, side dress rates, anything like that, even we sell these into wheat fields all the time, even though they're big. Everybody's like, well, that thing's just too big. Well, that weir in there at 30 degrees allows us to sell that valve in any application. So when you're trying to figure out what a guy needs, this valve is a real easy solution because it doesn't matter what his capacity is, what his demand is, the time of year, pressures, or anything like that. This thing has got all that extra 30 degrees to control at those lower volumes. So it's an easy solution for you to be able to supply your customers without having to make sure that that the rate is really small. Thank you. To make sure your low rate is really small. Oh man, I need to get a 1 inch valve. It's a higher rate. I better get an 1 1/2 inch valve. Well, this 1 1/2 inch valve can go all the way down to 5 gallon a minute effectively, and go all the way up to 70, 80 gallon a minute effectively. So, and especially now with all of the flow meters are all 1 1/2 inch, pipe threaded. Well, old school. I mean, a lot of Victaulics as well, but it allows for easy pump plumbing as well. So you can come straight out of your flow meter into an 1 1/2 inch pipe thread, all the way out into your product feedback adapter with just the same pipe thread. You don't have to worry about necking down, bushing up, anything like that. So it's a little more flexible. It's a lot more flexible. You carry one valve, it'll do everything. All they have to do is adapt to the pipe thread depending on what they have. Okay? Yes?
Good. We sold just a fast close valve.
Yeah.
And what you started noticing is when a system is divided into 5 sections, those fast close valves struggle at trying to regulate when we get down to
Yes.
2 sections.
Yeah.
That valve is going to
Yes.
assist in that, correct?
Yeah, no, it's
Number one, it's going to be a 2-valve system, right?
Yep, yeah.
Go ahead.
No, it's a very good point. Especially with now when we have sectional valves, we have end rows and point rows. So the guys are shutting off, half their toolbar. Well, all of a sudden that big 1 1/2 inch valve that they needed on that 62.5 foot bar and at 200 pounds, now it's a 30 foot bar at 200 pounds. And when you start trying to control, with a huge 1 1/2 inch ball, when you get down below, it just takes 5 degrees of turn to change 10% of your volume. A lot of oscillation. You're going to get a lot of open, close, open, close, open, close. So where this valve, you don't get that. It'll do 62.5, great. And then when it gets to an end row or a point row, he starts shutting off his bar. This thing will throttle back down nice and smooth. You'll have that extra 30 degree in the weir to choke it down real low. You don't get that oscillation. much smoother. Yeah, good thought. Thank you very much. Any questions on this one? It does come with standard KZ connections, not KZ, excuse me, Raven style Connexall connections. The cal numbers are the same on our control valves, 21, 23, and we do sell the fast valves as well. I know there's shockingly, I was really surprised how many people still use those fast valves. It's apparently pretty popular. Honestly, it's a great upgrade opportunity for anybody who needs to buy a fast valve. Sell these guys a 2-valve system and a new wire harness. They will thank you every day for it. Those fast valves are troublesome. They burn out fast. Every time you turn around and drop your bar on the ground, it's got to open up and find itself again. So the first 15 seconds of application rate is bouncing all over the place. A 2-valve standard, as soon as he drops his bar on the ground, he's on rate immediately. That alone is worth $1,500 to upgrade. And most guys will look at that as well as, they just don't understand, the benefits until they actually do it. And then they'll wonder why in the hell they've been doing this all these years. So yeah. And of course we do sell the fast valve as well. So the guys are stuck on it, and that's cool. 0743. So it's a standard cal numbers. You don't have to, when it comes to service and support, you don't have to learn anything new. It doesn't matter whether it's a Continental or a KZ or a Raven. It's still the same cal numbers. So, and if you tweak those cal numbers, it's going to affect it the same way. Backlash, all those, or valve speed, all that is still the same. Okay? Any questions on that? So I think that's it for that. But I think I asked Lucas just to throw in one of these splitters. So this right here is a jumbo splitter. This is kind of what we were talking about before. The holes in here are much larger and than you're going to find in anybody else's equipment. And this is what we still have to test a little bit when we start talking lower rates, because it's a pretty big hole. It's 1 1/8 hole. That's pretty big. So we want to test it to make sure it goes down to the lower rates. But when you're talking about cold weather, high rate, low tank pressure applications, these big jumbo manifolds really do a great job letting it breathe. And that translates all the way into the manifolds as well. So you need the rate to get through here and get through your manifolds. Okay. Ours is 3/4 inch pipe threaded, which sometimes turns people off. But at the end of the day, most guys are sectional shut off anyway, and they're running high pressure hoses. So you have to put a swivel in here anyway. So you can get a 3/4 by 1 inch swivel if you want to use 1 inch hose. And the primary reason why we made it 3/4 inch years ago is we want to try to encourage people to move to 3/4 inch hoses, especially on these big bars. These guys got 5 manifolds. There is no need to have 5 1-inch supply lines when you only have 1.25 inch pipe feeding it. So if you can imagine the expansion, remember we talked about 600 to 1, expansion rate, these kinds of things. This all plays a part into that. When you come into a splitter and you go into 5 or 6 1-inch hoses, well, you're not going to fill it up with liquid. You're going to fill it up with vapor. And that backs the system up. So it's harder. You still got to get all that vapor and liquid through the system. So anytime you have that issue, it's just going to end up filling up with vapor and then having to push that additional vapor through the manifolds. So we still, on the 3 outlets, we still go with 1 inch is fine. But when you get up to 4 and 5 and 6, we're trying to encourage people to go to 3/4. It's difficult, and because the availability, nobody carries 3/4 inch hoses. So we get that. But back when my uncle and I first were working on this thing about 10 years ago, we really wanted to try to improve people's application rate, encourage them to go to a 3/4 inch by putting the 3/4 inch pipe thread in there. And even if, like I said, if they want to stick with 1 inch, it's no big deal. You got to put a coupling in there anyway. Okay. Is there any questions on that? Yes, sir.
So, like if a guy has a 17 knife and he's in dire need of something, because you make those all
specific sizes.
Yeah, we do 3/4, 5s. Yeah,
Is it fine to plug?
you can. Yeah, you can. The vertical dam is a little more susceptible to plugging than the 360. The 360 is not, because we come into the top. You know, the MVD, if you kind of remember, it kind of swirls. So when you're swirling like that and you plug one here and your two outlets over here, you know, it really doesn't jive as well. But this one, we come in from the top. So you can plug off. It works just as good. So it makes it a little easier if you try to inventory some, like maybe a 5 outlet, you know. We want to try to keep it, though, a little bit as best we can. You know, I wouldn't want to plug a 3 and turn it into a 2, you know, but a 5 turning into a 3, a 5 turning into a 4, yeah, easy. It works just as good. Okay. Any other questions? Yes.
I'm gonna repeat something you said earlier, and that is, if I've got a manifold pressure gauge up here where I can read it, line up.
Yeah.
That manifold pressure gauge on a day where there's, let's say it's 60 degrees, right?
Yeah.
And it's operating, and the manifold pressure is, you said 50, 60, whatever.
Yep.
And then I get to that day where I'm down, it's close to freezing. I'm going to have the same manifold pressure to flow that same rate.
That's correct.
Even though the temperature has changed.
Correct.
The manifold pressure is still going to be almost like it was a liquid that was going through it.
That's right.
That's right. It is. It's a cool.
That's right. Yes. Yeah. So yeah, you still it's a good way to gauge your system. And now if you know, if same set of manifolds at 200 pounds in an acre at 6 miles an hour in the spring, fall, summer, winter, that manifold pressure was 55 back then. It's got to be 55 now. You know, so it's always going to need to be 55 at that speed at that rate. So the colder it gets, you know, you're just going to drop and you're closing that gap. So when you get down closer, you get off into that, you know, 70% rate, you know, you start getting into there, it's going to start backing up and people are going to have to start slowing down. And that's one of the reasons why we're looking at, you know, I think we've been talking a little bit about a pump system. I think we were working Lucas a little bit about it. We're going to be introducing a pump system. So there's 2 ways to address that. One is to get bigger manifolds, or, you know, incorporate a pump system. So, but just keep that in mind. The colder it gets, you know, and the smaller the manifolds, higher manifold pressures, lower tank pressures, you start closing that gap, it gets to be a problem. Okay. Yes.
I'm going to run one other thing past you.
Yeah.
If you've got system gauge for all the control valves and such, past the
Yeah, like before the control valve. Yeah, I know what you're talking about. Yeah.
So, what's the acceptable pressure drop between the tank and the system before you start seeing issues?
Yeah. So that varies between hose sizes. Okay. You know, so if he's got a 1-inch hose, 15 pounds wouldn't be out of the ordinary. 1.25-inch hose, 10 pounds. 1.5-inch hose, 5 pounds. Yeah. So bigger the hose, which, you know, less pressure drop, which is where capacity comes from. We've talked about that a little bit. You know, how the better the supply, the higher the rate. Well, that's because the cooler doesn't have to work so hard. You know, when the more pressure drop, more vapor, harder for the cooler to operate. Less pressure drop, less vapor, easier for the cooler. So, pressure drop along through there is critical. And that's a good way, you know, if it's more than that, you know, I would start looking at Y strainers being plugged, you know, hoses collapsing, or even toolbar couplers malfunctioning, you know, not opening up all the way. Okay. Okay. Any other questions? Well, listen, I want to thank all you guys. I really appreciate the opportunity. I don't get much chance to come do this, so I've enjoyed it, enjoyed meeting all the new faces, and thank you again, Tom, Kent, Todd. I appreciate you guys. Thank you. If you guys need anything, I'm easy to get a hold of. I'm the after-hour support guy, so you're always going to get me. It's, I could have given it, but I love doing this stuff. I take calls at 10 o'clock at night. I don't mind it. On the same thing with the holidays, I really have a passion for this stuff. So I don't mind helping people when they can't find the help. I think that separates us from everybody else. We're easy to get a hold of. I feel like sometimes I help people with Raven more than I do with Continental stuff. And I don't mind it, because I'll earn a customer that way. So, don't ever hesitate to give us a call if you need help on anything. Okay? All right. Thanks, guys.